Hello everyone, welcome to topic 7.6, properties of the equilibrium constant. By the end of this, you should be able to represent a multi-step process with an overall equilibrium expression using the constituent K expressions for each individual reaction. So you can find the K or Q value for an overall reaction if you know the value for K or Q for each step of a multi-step reaction. This is similar to Hess's law, but the rules are a little different due to the nature of K or Q as a quotient. So when you do this, you end up, the way I remembered it is to do the next math higher. So to make the reactions work, if you end up flipping the reaction, right, you flip the reaction around. In Hess's law, we multiplied delta H by a negative sign and flip the sign. Instead, when we flip the reaction, we flip K, right? So we take the inverse of K. If we multiply the reaction by a factor, so in this case we're multiplying by 2, we take it to the exponent. So okay. Then if you combine two reactions, so when you add the reactions, you're going to multiply their K values. And we see that here. Okay, so here's some outlines for what we're going to do in the examples. So looking at our example here, given the following reactions, calculate the value of K for the overall reaction, which is the bottom one. Okay, because that's the only K we don't know. So these two, at some point, I need to add them together to give me this one. Okay, so when I look at this, I see I don't need the D that is here. And I also, I think that's the only one we don't need. But if we also pay attention, I see I need a 2 in front of the E, and I need a 2 to cancel out that D. So I'm going to multiply all of this by 2. So 2 here, 2 here, 2 here. That tells me I'm going to square this. So when I add these two together, the D cancels out, and I'm left with A plus 3B plus C plus 2E left over. So that tells me that I can combine the two K values. So my K overall has to equal K1 times K2. And my K2 has changed because I changed my mole ratio. So I'm going to take 5 times 15 squared. And I'm going to combine all of that, and I should get 1,125. Okay, so it's similar to Hess's law, but like if you multiply the reaction by a factor, you take the K value to an exponent. If you flipped it around, we would inverse the K value, so take it to the negative 1 power. And when we combine K values, we multiply their numbers. Okay, so let's look at this we do. Given the following reactions, A, calculate the K value for this reaction. Okay, so our first step is to identify the ones that we need. So I need this one, this one, this one, this one, and this one. Okay, I'm going to compare them then to the side they are on in the original reaction. I see first that X2 is on the wrong side, so I'm going to flip this. I see that the HXCl is on the right side, so I'm going to keep it. It's fine. And the chlorine is also on the correct side. Then I look at the water and the hydroxide ion. And they are on the wrong side, so I'm going to flip that one as well. And when I flip those, I need to take these to the negative 1 power. Okay, so rewriting this to show that it combines, you can rewrite it, and I'll do that real quick. So hx minus x2 minus plus h plus, and then our next one stays the same. And then finally flip the other. Okay, so now that we have this, we can cancel off what cancels, so it's the same on both sides. So the HX ion, the hydrogen ion, and I think that's it. Ooh. Yep, that's it. So then we add it all together, and it does give us the overall reaction. So then we take K is going to be equal to the product of these three, and I can call this K1, K2, K3. So K1, so since we added the reactions, we multiply these. So 5.8 times 10 to the negative 4 to the negative 1 power, because I flipped the reaction, times 6.2 times 10 to the 9, and we leave that one alone because we did not flip it or manipulate it, times 1.0 times 10 to the negative 14 power to the negative first, because we flipped that reaction. And when we finish solving, we see that we get 1.1 times 10 to the 27th power. Now B says, at equilibrium are the products or reactants favored? If you look at the size, the magnitude of your K, that tells you that this is product favored. Because it is greater than 1. It is a lot bigger than 1. Okay, so that completes the 7-6 notes. Please finish the you do, check your work, and thank you for tuning in.